Alright, so we know that a of x for green is 1/2 pi r squared. This is a half circle. So it's pi over 2, whatever our r is. What's my radius here? Sine x over 2. We only want half of it. That's sine x. Half of it is sine x over 2 squared. So there's my a of x. And once you have that, I guess you could make that over 4. So it's basically pi over 8 sine squared x dx from 0 to pi.
Aren't you squaring the 2 at the bottom of the sign?
That's how we got 8.
Yeah, so that's 4
Oh,
times 2.
yeah.
Yep.
So is that what they're asking you for? In the
That
fall?
will give you the volume. Well, that'll give you, that's the integral in which to find the volume.
So then, do we need to analytically integrate that? Or
Yeah, if you were going to, you'd have to do a power reduction.
Yeah.
But you can, if you want to save time in this assignment, I don't know if you read that in the notes, but you can do your integrals on your calculator.
Yeah.
Okay, on the tests and quizzes, you will be asked to do them by hand, but there's nothing new as far as integrals go, and if you wanna practice, you can, but if you wanna save time, you can just plug it in your calculator. So maybe go through one time through the assignment with your calculators, and then if, in preparation for the test or quiz, you can maybe go back and try a couple by hand.
I figured out my calculator was in degrees, that's why it wasn't working.
Oh, nice.
Yeah.
Okay, so that's one type of a volume, cross section. Let's say I have to, I'll do one more example. I'm never gonna make it through all the work, all the notes today.
You tried really hard.
Probably go through maybe
So what does
3
this section
types.
really do?
we watched
Yeah,
the
it's,
first.
the homework quiz would potentially be Thursday at the earliest.
We watched the first couple on Friday. Like we
That's
watched.
awesome.
the
Shh,
video.
we said we wouldn't
So
tell them
where
to
did-
be smart.
I already heard, yeah.
Sorry.
Oh yeah, sorry.
So where
But
did you
then
go to
maybe
my
we wouldn't have
YouTube
to do
page
as
then?
much.
Yeah, they were.
We wanted
It was
until you were
confusing.
done with like what you did. Like it was weird because you were doing it on a Friday, and you were like, oh, but we'll do this stuff on Monday, which
Oh,
is like actually
perfect.
kind of what
Yeah.
we were doing.
Did I have brown hair back then?
I don't know.
It's not what we're
You
trying to
didn't-
pay attention to.
Yeah. Then you changed outfits because we went into Frisbees and watched, and we were like, oh yeah, it's Monday.
You're definitely explaining better in person than on the
Okay.
video.
We went to.
Alright, so let's do,
Yeah, you improved that teaching.
well, that's great. Now I gotta think of an example.
Haha.
Do the diners.
Put you on the spot. Those are
Triangle.
Area of
X equals y squared.
Let's just do it.
Let's
Just
do
x
this
between
plus or minus
0
square.
and 4. Find volume,
It's a sideways parabola.
right. Whose cross sections
You should really switch back to graph paper now.
are,
You switched
we'll say squares to begin with, but then I'm gonna make it more difficult. Okay, so the squares in whose base are in x, y plane. Alright, so I'm going to draw this one for you too.
Alright, I'm not
X, Y, Z. This is the only type of problem that I graph in 3 dimensions, if it makes it feel better. So x equals y squared is a parabola that looks like this, right? Did we know that?
Yep.
Because you could solve for y equals, so it'd be square root of x and negative square root of x. So there's my sideways parabola, and I said that would go up to 4. Okay, so there's my region.
Are our calculators graph in 3 dimensions?
I think the 89.
84 scan? That's boring.
We probably can't do 89.
That'd be so cool.
Those cross sections are squares based in the xy plane that connect with these here's
There.
one of my cross sections.
It's really hard to draw this all in the same color.
What flavor? Wow. Oh, I just realized I needed to
What's
drop.
that one?
And
So
it's
see if you
square.
can find that volume.
Okay, I got that. But what is? Oh, I've got it.
It's like
It's a tornado.
Oh, top, that's our tornado, yeah.
Dunce hat.
Okay, so using the disk method, it's always going to be integral of pi r squared. And if we're going around this is new, if we're going around a horizontal axis, which we are, you will always be integrating with respect to x. So the next example, we're going to go around a vertical axis, and we would have to integrate with respect to y. So in this case, it's from 0 to 2. My r is just x squared. So pi x squared squared dx from 0 to 2. Anybody get that?
I got that.
Nice.
That's like the first time I've raised my hand in this like semester.
That's like the first thing that would have been like.
I get to raise it.
Anyone get that?
Mark it on the calendar. Where's that even come from?
They don't even know that.
Just whips it up.
In Smith's class, I had just the screen here, and I had both of these in my pocket like this. I'm literally playing.
That's funny.
Because, you know, everything that he says is super important.
Yeah.
I'm glad you could agree.
Sure, you get a lot of this.
Okay, I'll cut the sound of this part.
Alright, so area enclosed by the y-axis, y equals 4, y equals 2x, and we're going to revolve around the y-axis.
Oh boy.
So there's my area. And we're going around the y-axis, so you can
Damn. Look at my phone. I was gonna want this on.
Whoa. That's a really good comb.
Darn.
Hi!
Special guest.
It does. I don't even know why you have that.
Well, I couldn't convince
I thought for sure I left it somewhere. Okay,
Had no comment. Oh, you don't get to use your tray today.
I know.
Sad.
Alright, so we're going around a vertical axis of revolution, so we're going to integrate with respect to y. Can you see that our volume, our shape, is going to be solid? There's no gaps in it.
Correct.
Now do an example, that's the next technique. But you see that it's a solid cone.
Yes.
It's not like you can hold water with it, it's not like a bowl or anything, it's solid. So since it is solid, we would use the disk method, so it's pi r squared, in this case it's dy from 0 to 4. So what is my radius?
Y over 2.
Do
X.
2x?
Y over 2.
Okay, our radius is x, right?
Oh, yeah.
So why, yeah, why
But we need it in terms of y, so what is x?
Angel
X
C.
is y over 2. So we have to write it in terms of y. So it would be integral of pi y over 2 squared dy from 0 to 4.
Oh goodness, I got that just a couple seconds ago. Wait, say it again. Who got that?
Anybody get that?
Is this crazy?
And when I say anybody, it makes it sound like, oh my gosh, you got it. Did Did anybody actually get that?
Oh my god.
Okay, questions on that? That is the disk method.
I like that method.
This is the confidence.
I like it, but then the washer method's not even bad because it's the same thing.
It's not too
where you
bad.
just subtract another
Right.
distance.
Oh,
Snapperoonie.
I don't like cross section.
All right, let's tackle
You
the
scared me a lot.
washer method.
Walking
Now you
so
sound
much
super
with
smart in
this.
the video.
Like,
Like you're ahead.
no, what?
Now you sound smart on the video, like you're a step ahead.
Remember that? That's the secure camera.
Oh, I cut that part out.
Yes, yeah. Zoomed in on me.
Did you get the shot?
All right, so let's say we've got let's see, y equals 2 squared x, y equals x, and we're gonna go around the x-axis. Alright, so we're gonna make our sketch. 2 square root of x, regular square root of x looks like this. 2 is gonna make it a little steeper.
degrees.
That's
Stop it.
y equals 2 square root of x. And y equals x. Looks like this. So here's our area. And we're going to revolve it around the x-axis.
Oh dear.
So are we integrating with respect to x or y?
X.
X.
X, because we have a horizontal x, it's a revolution. Now every example I've done so far has either been the x-axis or the y-axis.
No.
We can revolve it around like y equals -1. We'll do that next.
Oh, I thought
We
you were
revolve around
going
this.
to say
Revolve around
I thought
the
we
z.
were down to Z.
That's what I thought.
I don't even know what it looks like
I don't know
yet.
what you-
It's just the one that goes up. It's
Okay,
hard to draw though.
so
How would you even do that?
we're gonna visualize what it looks like. I've got 2 R's. I call that the little r.
The little R. What in our nation?
Did you see Hunter's tweet? What is Spartan Nation? And it's cozy with the cowboy hat.
And then I've got big R.
What in our nation? More manly our nation.
What an exact
That's big R.
quotation. We can make so many.
Revolutionation.
So can you visualize what kind of shape we're gonna get?
Yes, a washer.
I had.
Well, washer's the cross section.
Oh.
What kind of, it's gonna be like
It's like a bowl.
it's gonna be a bowl, right?
Yeah.
I had a good idea before you drew this.
But it's just gonna really.
Can you see it's like a sideways bowl?
Yes.
Alright, so the washer technique is you could find the volume of the entire thing
It's like the outside of
minus
your eye.
the volume of the inside. You could combine that into the same thing as by just going pi big R squared minus little r squared. In this case it's dx.
Oh my gosh.
Okay, so it's just the big R squared minus the little r squared.
That's a lot easier than I thought it was. Why'd you use brackets?
So we're integrating from here to here. Where am I integrating from? What do I have to do?
Have this
Zero.
something equal to each other.
Right, find the point of intersection.
0
So,
and
so I have 2 square root of x equals x. Square both sides, 4x equals x squared minus 4x equals 0, x minus 4, so it's 0 and 4 our point. So we're integrating from 0 to 4. And what is my big R?
0.
It's this y, right?
Yes.
It's changing.
Y equals 2 square root of x.
It's now we're gonna do it in terms of x, so we don't want to put any y's here, so right, it's 2 square root of x squared minus our little r.
X.
It's the little y, which is equal to x. Good. X squared. And that'll get you there. good question. So you would have to use the washer here because it is hollow on the inside. Your cross section will be a washer. All of our cross sections here were discs. Okay, so it's a washer, it's hollow on the inside.
How do you know that it's hollow on the inside?
Well, because there's a gap between the axis of revolution and the area. So the area's up
There's two
here.
equations.
If the area is like surrounding the axis of revolution, or right next to, adjacent to it,
It's filled
then it's gonna be solid. But if there's a gap there, then that's where you're gonna have area volume on the inside.
Alright, I'm feeling pretty good. Let's just do homework now.
The homework's
There
hard.
is lots more methods.
Okay, yeah, well, there's only one other type of method.
Nope.
These are about as easy of problem as I could think of. Just to squish your confidence just a little bit. So let's try to revolve it around y equals -1.
Then you just change the equation of the reference washer.
Okay.
Right? No, the
I cleared
radius,
it up.
the radius
So we
changes.
just add one
The radius
Yeah, X
just
plus
changes.
one.
to each one.
It's still
X
dx.
minus 1?
My
Yeah, minus
boundaries of integration is still from 0 to 4. So that's what the book's going to do. It's going to say, here's our area revolved around the x-axis, revolved around the y-axis, revolved around y equals -1. So in this case, what is my big R?
R plus one.
Yeah, something plus 1.
Big R plus one.
That's right.
Square root of x.
So square root of x plus 1. Yep.
Oh,
Oh, yay. I can do this.
We can do this.
Oh, I said I can. I don't know about you guys.
oh. But
And
I
your
was
little r?
X plus one.
X plus 1. That'll get you there.
Why did you try to scare us?
It's not that bad. If your sketches, just remember that the r's are distances. So some people like, oh, if it's y equals -1, that means it's going to be +1. Don't try to memorize it. Just figure out that r is, it's just a distance. How far is that? Well, I know that big R is this, +1, exactly like you said. Let's try revolving. This is our last one we'll do. Let's revolve the same area around the y-axis. See if you can figure that out.
Stop.
So, going around the y-axis, that means we're integrating with respect to
Y.
y. Is this hollow or solid?
Hollow.
So we're going to do the washer method. So it's pi r squared, little r squared, dy. So we're integrating from 0 to,
If you solve it, it's four.
is it 4, 4?
It's zero.
Oh, that would make sense.
Yeah.
Yeah, so this point is 4, 4. And if you did 0 to 4 and you lucked out that it happens to be 0 to 4, you understand that this is a different 0 to 4 from going here to here.
Yeah.
Okay? So 0 to 4. My big R is this, which is x, because it's coming out here. And that x is squared, so that's y squared equals 4x. Is it y squared over 4?
Yes.
Yeah.
That's your small
That's
x.
your big one.
That's your
That's
small
my
x.
big R.
That's
No,
your-
that's my little r. Sorry.
I was like, if I got
There.
Yeah.
I might.
Oh, x is just equal to y for the big
So
one,
just
right?
Y.
Y squared minus y squared over 4 squared.
Wait.
Nobody got that, did they?
Wait, why is
Yes.
why is y equals x the big R?
I understand this section.
Because we're revolving around here, so the big,
I understand that, but just the amount of time is very good.
that's the big circle radius.